photoelectric effect. Okay, and some part of energy also I will cover here only. So let's see, this was the setup. This was discovered by, yes, Halvorsh and Lenartz, but it was explained by Einstein. And who got the Nobel Prize? Einstein got the Nobel Prize. Okay, yes. So what you have, see, once again, what you have this evacuated chamber. I've explained you already. Yeah? This is your evacuated chamber. In this evacuator, see, this is your evacuated chamber. Here you have a source. This is your quartz window. Here you have a photosensitive plate. Okay, then you have a micrometer, then you have a voltmeter. You have to understand three things. What is the meaning of photoelectric effect? Photo means light, electric means current. If light is producing current, then it will be known as photoelectric effect. Okay, now let's see what's there here. What we have next. Okay, yes, we have three things. We have frequency, we have frequency, we have frequency, we have intensity, and we have potential difference. We have frequency, we have intensity, and we have potential difference. Okay, what is the meaning of frequency? Frequency means color. And in another words, it can also be known as energy. Okay, what is the meaning of intensity? Intensity means brightness. In another term, you can also write it as number of photons. Last is potential difference. What do you mean by potential difference? Potential difference means voltage. So we have three things. Okay, frequency, intensity, and potential difference. What three things we have? We have frequency, we have intensity, we have a potential difference. Frequency means what? Frequency means color. Another word for frequency will be, it can also be known as energy. It can also be known as energy. Wait, huh? First is frequency, another one is intensity, third is potential difference. Okay, yes, we have three things: frequency, intensity, and potential difference. So frequency, first we have frequency, second one is intensity, and third is potential difference. I'll make like this somewhere because we're getting too much small space. Yes, the first thing, what we have first we have frequency. So in the first case, we will take frequency. Okay, here we will vary frequency. And the other two parameters will remain constant. What are the two parameters? Intensity and potential difference will remain constant. Okay, then first is frequency, and intensity and potential difference will be constant. Second, what we have? Second, we have intensity. When we will be studying about the intensity, and if you are varying intensity, then the another two parameters will be constant. What are the other two parameters? Yes, the other two parameters will be frequency and potential difference will remain what? Constant. And if we are varying potential difference, if we are varying potential difference, if we are varying potential difference, then what will happen? Then our frequency and intensity will be constant. Okay, yes, so we have, if you understand just this much, you will be able to write 4 marks of theory. Okay, so we have three main parameters, which are those three parameters: frequency, intensity, and potential difference. Frequency means color, intensity means brightness, potential difference means voltage. Okay, yes, if you are varying frequency, intensity and potential difference will be constant. If you are varying intensity, frequency and potential difference will remain constant. And if you are varying potential difference, frequency and intensity will remain constant. Okay, now what? Yes, first what we did, frequency means what? Frequency means color. Frequency means what? Frequency means energy. Okay, yes, let's see about more about the frequency. Frequency, how? Frequency, what? Frequency, see, we have frequency, energy is equal to h gamma. If we are increasing frequency, that means energy will be increased. Why? Because h is constant. No? Yes. So see what is happening. First, what I did, what I did, I strike the photon of frequency 1 unit. I saw that there was a no deflection of the current. There was a no deflection of emitter. That means no current is flowing. If current is not flowing, that means electron is not emitting. Once again, I increased the frequency to 2. Once again, I saw the same thing. What? That micrometer was not showing the deflection. If micrometer is not showing the deflection, that means there will be no flowing of current. If there is no flowing of current, that means there will be no emission of electron. That means 1 and 2 are just waste of the time. Once again, what we did, then we increased the frequency to 3, then we increased the frequency to 4, then we increased the frequency to 5, then we increased the frequency to 6, then we increased the frequency to 7. Till 6, I saw the same thing. What? That this micrometer was not showing any kind of deflection. If this is not showing any deflection, that means current is not flowing. If current is not flowing, that means electron is not emitting. But after 6, when I increase the frequency to 7, I saw that this micrometer shows a deflection. If micrometer is showing the deflection, that means what? If micrometer is showing the deflection, that means the current is flowing. If current is flowing, that means what? If current is flowing, that means electron had been pulled out of cathode plate. Okay, pulled out of cathode plate. See, this is your cathode plate. This is your cathode plate. When light struck here, electron was flowing. Electron was flowing. And this electron this electron was flowing, and this anode, as anode is a positive plate, this positive, this positive affect this electron, and there was a closed circuit. That's why current started flowing. That means what? That means that not every frequency, not for every frequency there will be production of current. Not for every frequency there will be emission of electron. After reaching certain frequency there will be emission of electron, and that frequency is known as what? Yes, that frequency is known as threshold frequency. So we got one most important definition, which I have already explained you, the new term, that is threshold frequency. Okay, after that, this was explaining by whom? It was explaining by Einstein. Okay, Einstein told that this is one photon one electron phenomena. And Einstein told that light can never be a wave. Why? See, if light would be a wave, this is our metal surface. If light would be a wave means plane wavefront. If plane wavefront is coming, and here we have electron, each electron will take energy from that wave, and after getting energy completed, it will remove. When this will get sufficient energy, this will remove. When this one will get a sufficient energy, this electron will remove. When this electron get a sufficient energy, this electron will be removed. But this was not happening. After certain frequency, when one photon was coming, one electron was emitting. One photon was coming, one electron was emitting. That means what? This was an instantaneous emission process. Einstein told, okay, these are instantaneous. These are instantaneous emission process. Instantaneous emission process means what? It means it was a one photon one electron phenomena. This was one photon one electron phenomena. Okay, yes. Then what happened? See, first, if we were increasing the frequency and another things were constant, then we got threshold frequency and we got instantaneous emission process. One photon one electron phenomena. Okay, now what? Now we are going to study about the varying intensity. Varying means increasing the number of photon. If number of photon will increase, as more number of photon will come, more number of electron will get emitted. Okay, that means what? If more number of electron are removing, that means more photoelectric current will be produced. Okay, so this was as simple as increasing the intensity. There was increase in the photoelectric current. Why I am not writing only current? Because this current is produced by what? It is produced by photon. That's why it will be named as photoelectric current. Okay, yes. Now what? One more thing you will have to understand here. See, I'll change the marker and I will write here. If you are increasing the frequency, even kinetic energy was increasing. Anyone can tell why this kinetic energy was increasing? See, if we are increasing the frequency, energy will increase. Yes, energy will increase. If let us consider that the metal plate has a work function of 2. It has the work function of 2, and if we are giving only two frequency, so what will happen? It will only remove. Okay, but if we are giving 3, it will remove by 2 and it will move by 1. If we are giving 4, it will remove by 2, it will move by 2. If we are giving 5, it will remove by 2, it will move by 3. If we are giving 10, it will remove by 2, and with 8, it will increase. So just see now, if we are increasing the frequency, some will used for removing and another one will be used for moving. If we are increasing the energy, ultimately what will happen, first we will use it for work function, and another we will use it for increasing the kinetic energy. Okay, but increasing the intensity was not having any effect of on kinetic energy. You want to increase number of photons to n times, there was no change in the kinetic energy. Okay, why there was no? Because see, intensity was just removing the electron, it was not responsible for moving the electron. So by increasing the intensity, there was no change in kinetic energy. I hope I am clear till here. Okay, frequency, intensity, done. Now we have the last part, that is a potential energy. That is potential. See how we can vary potential. We can vary potential like this. That means increasing the voltage, or we can decrease the voltage. Okay, and another two parameters will be constant. Another two parameters will be constant. Now see what we have. Yes. First, we will increase by positive potential difference. First, we will increase by positive potential difference. If we increase the voltage, let us consider that I am giving voltage of around here. I am writing, I am giving voltage 1 volt. I will get 1 ampere. If I increase it to 2, I will get 2 ampere. If I increase it by 3, I will get 3 ampere. If I increase it by 4, I will get 4 ampere. If I increase it by 5, I will get 5 ampere. If I increase it by 6, I will get 5 ampere. If I increase it by 7, I will get 5 ampere. If I increase by 8, I will get 5 ampere. That means what? That means if we are increasing the voltage, current will increase, current will increase, current will increase, current will increase, and then current will get constant. That constant flowing of current is known as saturation current. Okay, once again, if we are increasing the voltage, current will increase, current will increase, current will increase. After that, current will flow constantly, and that constant flow of current is known as saturation current. Okay, so I am writing here, initially increasing the voltage, current will increase, then 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 current saturates. Okay, then what? Then if we are decreasing the potential difference, if we are decreasing the potential difference, decreasing means if we are giving negative potential difference, then what? If we are decreasing, I will erase here. Yes, if we are decreasing, so what? See, decreasing means what? Yes, if we have 2 volt, let us consider that we were having 2 ampere. If I did 1 volt, sorry, if I did 1.5 volt, decreasing, sorry, decreasing means negative potential difference. Negative potential difference. Okay, yes. So see, if we are in decreasing, giving negative potential difference, that means if we are giving minus 2 volt, we are getting 2 ampere. If we are giving minus 3 volt, we are getting 1.5 ampere. If we are giving minus 4 volt, we are getting 1 ampere. If we are giving minus 5 volt, we will be getting 0.5 ampere. If we are giving minus 6 volt, we are getting 0 ampere. If we are giving minus 7 volt, we are getting 0 ampere. If we are giving minus 8 volt, we will get 0 ampere. That means what? Initially, if we decrease the voltage, current will get drop, current will get drop, and then current will going to stop, and that point where current stops is known as stopping potential. Okay, initially I will write here, initially when voltage is decreasing, current decrease, then current stops, and the point where current stops is known as stopping potential. Okay, it is known as stopping potential. Once again, yes, so these were the things. Okay, yes, we have more things to discuss in the next slide because here we don't have a space now. Okay, so what we studied that we have three things: frequency, intensity, and potential difference. Okay, what happened when frequency was varying, what happened when intensity was varying, what happened when potential difference was varying, we studied about that. Okay, now what? Now we studied about the saturation current, and we also studied about the stopping potential. Okay, saturation current will be represented by V saturated, and stopping will be represented by Vs. Okay, yes, so see now. I am just erasing this part. I have to write and give you more information here. Okay, after this I will explain you the diagram also. Frequency, intensity, and potential difference. Just understand that. Now what? You are varying the frequency, intensity, and potential difference will be constant. Now, now, what we are doing? We are varying the frequency. Let us say that our frequency, first our frequency will be, yes. Okay, yes, frequency varying, intensity and potential difference will be constant. So what? If we are varying the frequency means first we will have frequency 10 hertz, then we will have frequency 12 hertz, then we will have frequency 15 hertz. Like this, something we have. Like this, if we have something, then what? If you will see your saturation current will always be positive. Huh? First, for having constant current, you were needing 5 volt. Means if you are giving 5 volt and your frequency was 10, it will be going to saturate, means constant current would flow. But if you increase the frequency, instead of 10, if you are giving 12 now, so your saturation will not happen at 5. At 5, there will be no constant flow of current, but it will be at what? It will be at 7 volt. Okay, if from 12 to 15, from 12 volt to 15 volt, if you are again increasing the frequency, what was happening? First it was stopping at 7, now it will be stopping at what? Now it will be stopping at 9 volt. From 10, at 10 it was 5 volt, at 12 it was 7 volt, at 15 it becomes 9 volt. But if you speak about the stopping potential, But if you speak about the stopping potential Vs, it was constant. It was stopping at 5, again it will stop at 5 only, again it will stop at 5. That means increasing frequency will affect saturation current, saturation voltage, but it will not affect the stopping potential. And this was reversed for intensity. Okay, this was reversed for intensity. What for intensity? What for intensity? Now see, if we have intensity 10, 12 and 14, here saturation at 10, saturation will be 5 only. It will be 5 only. It will be 5 only. Why? Because saturation will be constant, and for stopping you will need something. Yes, for stopping it will change. First it would be -7, then it will be -9 volt, then it will be -11 volt. Saturation will be in minus. Okay. Now, why it is happening? The problem is why it is happening. See, if you are increasing potential, if you are increasing the potential, if you are increasing, that means what? See, this is positive, this is negative. This is positive point, panic, positive, and this was negative. If you are increasing, that means you are increasing the strength of anode plate. If you are increasing the strength of anode plate, that means this anode will attract this electron forcefully. Okay, then if you are increasing the potential difference, okay, increasing, why it was happening in potential difference? If you are increasing this, so what it will do, see, the light is striking somewhere here, electron will come and it will attract the electron. Pause. Increasing, that means what? We are making this strong. It will remove all the electron from here, and now constant current will flow. Okay, if we are giving negative potential, that means what? That means we are giving strength to cathode plate. If cathode plate is given strength, that means what? It will not allow electron to flow. There will be no electron emission. It will avoid electron to go, but still there will be some electron who will have more energy than the energy of potential difference, and it will go. So that's why initially there was a flow of electron. It will get reduced. It will get reduced. See, not all electron have same energy. There will be some electron will have more energy. That electron will be stubborn electron, and that will go. But after some time, when those electron will go and they will make the current, and after that there will be no electron of that energy, and then your current will going to stop. Okay, so this was the thing happening. If you are increasing the frequency, kinetic energy was increased. I explained you, but for intensity it was not happening. Okay, yes, so these were the things we have to see in those three things: frequency, intensity, and potential difference. Now we will also see the graph of this. Okay, yes, now let's see each points one by one. First, and the schematic description of setup utilized for photoelectric effect experiment is shown in figure. It is made up of two metal plate, A and C, and thin photosensitive plate C inside an evacuated glass quartz tube. A sufficient short wavelength monochromatic light from source S enters the window W and later and lands on photosensitive plate C. The glass tube has a transparent quartz window sealed, allowing UV light to enter and irradiate the photosensitive plate C. The electric field produced by battery cause plate C to emit electron, which plate A then collect the variable potential difference between plate C and A. As a result, As a result, A can be kept in relation to emitter C at a chosen positive and negative potential. These electrons are drawn to collector plate when it is positive about the emitter plate C. The circuit electric current flows because of electric emission. A microammeter measures the resulting photoelectric current flowing in the circuit, while voltmeter measures the potential difference between emitter and collection plate. The potential of collection plate A in relation to emitter plate C can be changed to alter the photoelectric current. It is possible to alter the potential difference V between the emitter C and collector A. In addition to the intensity and frequency of incident light, the experimental setup shown in the figure can be used to investigate how photocurrent varies in response to radiation intensity, incident radiation frequency, and the potential difference between A and C. Okay, now we will see effect of intensity. It is having a simple graph like this. What does this graph shows? This graph shows that if you are increasing the intensity, photoelectric current will increase linearly. Okay, it will increase linearly. So, to attract the electron, released from emitter C, collector A is kept at positive potential related to it. Every time the light intensity is changed, the intensity, radiation frequency, and potential remain constant. The resulting photoelectric current is then measured. As the figure clearly illustrates, it has been discovered that photocurrent grows linearly with intensity of incident light. The photocurrent and photoelectron emitted per second are intimately correlated. This suggests that there is a direct relationship between the intensity of incident radiation and the number of photoelectron released per second. Then we have effect of photoelectric current. Okay, yes, let's see each one by one. If we maintain the positive potential between A and C, we apply fixed frequency gamma and fixed intensity I. Next, we progressively change plate A positive potential, measuring the photocurrent that result each time. It had been discovered that a positive potential rises, so does the potential current. The photoelectric current reaches its maximum or saturation when plate A reaches a particular positive potential and absorb all electrons that are released. The photocurrent does not increase when plate A acceleration potential is raised further. This saturation current refers to the photoelectric current highest value. When every photoelectron released by emitter plate C reaches a collector plate A, this is referred to as the saturation current scenario. We now apply a negative potential which is gradually made more negative to plate A in relation to plate C. Okay, now so the minimal negative potential applied to A at specific incoming radiation frequency for the photoelectric ceases to drop zero. It refers to as a cutoff or stopping potential. It is simple to understand the observation in terms of photoelectron. The energy of each photoelectron that the metal emits varies. When the stopping potential is high, to repel even more intense photoelectron, the photoelectric current is zero with the minimal energy of motion, so that your kinetic energy maximum will be equal to E V naught. Where what is V naught? V naught is just stopping potential. Now, if we have higher intensity I2 and I3, we observe that a greater value of saturation current are now observed in demonstration that in direct proportion to intensity incident radiation, more electrons are released every second. As a result, a stopping potential is independent on intensity radiation strength at a given frequency. Put another way, the maximal kinetic energy of photoelectron is not affected by strength of incident radiation, but rather by a material of emitter plate and the light source. Okay, now see. We have this thing. I will explain you how it is working. This is your photoelectric current, and here you have voltage. Here you have positive potential, and here you have negative potential. Okay, yes. Now what? See, I told you, if you are increasing the intensity, if intensity is first it is 10, then it will be 12, then it will be 14, then your stopping potential will be constant. It will be 5, it will also be 5, it will also be 5. But your saturation will change. First it was saturating at 5 volt, then it will be saturating at 7 volt, then it will be saturating at 9 volt. Okay, if you are increasing the intensity, stopping potential will be constant, but saturation will increase. Okay, yes, if you are increasing, then what happened? Yes, if you are increasing the saturation point, if you are increasing the intensity, see, first what happened? If you are increasing, if first we are speaking about the first one, that is 10 1. For that, if you are increasing the voltage at 5, it will saturate. At 5, see here, I'll say that at 5 it got saturated. Okay, sorry, somewhere here current got saturated, somewhere here current got saturated. If I again increase the intensity, then at 7 it will saturate. At 7 potential it will saturate. If I again increase the intensity at 9 voltage, it will saturate. But whatever the thing will be, if you decrease it, it will all together will going to stop here. And why that is known as that, and that's why that point is known as stopping potential. Sorry, not the question first. First we will solve some frequency. First frequency. What for frequency? Effect of frequency. On stopping potential. Okay, effect of frequency on stopping potential. Now see, we have already discussed about it. If you are increasing the frequency, first if it is 10 hertz, then it will be 12 hertz, and if it is 14 hertz, if you are increasing it, okay, so your saturation point, saturation point, your stopping point will be different. Where will be your stopping point? First it will be -5, -7, then -9, but saturation will all be together. If it is 5 volt, it will also be at 5 volt, it will also be a 5 volt. See here, check for three frequency. First one is this, second one is this, third one is this. Okay. We now examine the relationship between stopping potential and incident radiation frequency. We appropriately vary same light radiation intensity at different frequency and examine how collector plate potential affect photocurrent fluctuation. In figure, the resultant variation display for incident radiation at different frequencies. We obtain varied values of the saturation current, but the same value of stopping potential. The frequency of incident radiation determines the energy of electron released. Higher incident radiation frequency have a more negative stopping potential. Figure illustrate that if the frequency are in the sequence, then stopping potential are in order. Therefore, to fully stops them, we need more retarding potential. A straight line may be seen in a figure when the frequency of incident radiation and the related stopping potential for various metal are shown on the graph. The graph demonstrates that for a given photosensitive material, the stopping potential varies linearly with the frequency of incident radiation. The stopping potential is zero for specific minimum cutoff frequency denoted as V naught. There are two implications to these observations. Maximum kinetic energy is independent of the intensity of the incident radiation and varies linearly with its frequency. If the incident radiation frequency is less than the cutoff frequency, then no photoelectric emission can occur, regardless of the intensity. The threshold frequency is the lowest frequency or cutoff frequency. These all things I have explained you in the session. See next, the copper or zinc are less sensitive than the selenium. Different wavelength of light cause different reaction in the same photosensitive material. For example, copper exhibit a photoelectric effect in response to ultraviolet light, but not in response to green or red light. It should be noted that all the studies it was discovered that even in cases where the incident radiation was extremely weak, photoelectric emission began instantly and without any noticeable time lag if the frequency of incident radiation exceeded the threshold frequency. As of now, it is understood that emission occurs in less than 10 raised to 9 seconds. The experimental characteristics and finding covered in this part are now summarized as: the photoelectric current is linearly proportional to incident light intensity for particular photosensitive material and incident radiation frequency. The saturation current is shown to be proportional to incident intensity for a given photosensitive material and incident radiation frequency, but stopping potential is independent of incident radiation intensity. The stopping potential, or more accurately, the maximum kinetic energy of photoelectron released, arises linearly with the frequency of the incident radiation over the threshold frequency and is unaffected by intensity. Even when the incident radiation is made extremely weak, the photoelectric emission occurs instantaneously and appears to have no apparent time lag, 10 raised to minus 9 seconds or less. Okay. Let's see some question based on this. And the questions are: what is the term for the minimum energy required to remove an electron from the surface of metal? Minimum energy, work function. Okay, yes. Next one. Which the phenomena known as photoelectric effect occurs when metal surface is exposed to radiation with right frequency. The phenomena known as photoelectric occurs when a metal surface is exposed to radiation with the right frequency. Okay. Then, which of the following application of photoelectric effect in everyday life? Not a microwave oven, not in a bulb, not in the refrigerator, but in the solar panel. Light strikes, energy electron release, and the electron release will be stored in the form of current. What frequency correspond to the photon with energy 6.6, 66.3 electrovolt? Yes, see, most important conversion for the work function. Work function will be represented by electrovolt, and 1 electrovolt will be equal to 1.6 into 10 raised to minus 19 joule. Okay. One electrovolt will be equal to 66.3 electrovolt. Sorry. 1 electrovolt will be equal to 1.6 into 10 raised to minus 19 joule. Okay, now find the frequency of photoelectron of energy. Energy will be how much? 66.6, 66.3 electrovolt. Energy is 66.3 electrovolt. That means this will be 66.3 into 1.6 into 10 raised to minus 19 joule. You want to find the gamma. So we will write energy is equal to H gamma. So gamma will be equal to what? It will be equal to E upon H. E means 66.3 into 1.6 into 10 raised to minus 19 joule upon what is H? 6.64 into 10 raised to minus 34. This ones are, this tens are. approximately. Then this will be 16 into minus 19 plus 34. Minus 19 plus 34, 15. Let's search for this option. Let's search for this option. This will be the right answer. 1.6 into 10 is to 16. Okay? Yes. Yes. The next one. The threshold frequency in the photoelectric effect is what? Threshold means minimum frequency. Option B. Okay? Option B. How does the photoelectric current vary with intensity of incident light? Photoelectric current, intensity of light. How does the photoelectric current vary with intensity of incident light? Linearly. Okay, it will increase linearly. Why is a negative charge metal plate used in photoelectric effect experiment? Why negative? Why we are using negative charge plate? Negative charge plate are used in photoelectric effect. Negative, what it will do? It will repel the electron. Okay, yes. Then draw a graph showing the variation of photoelectric current with voltage incident of equal frequency and different intensity. Mark the graph for the radiation at higher frequency. You people know what about this graph. I've explained you about this graph. Okay, next. Yes, you can also solve this type of question. For that, I've explained it, everything in the detail. Now, same here. Draw a graph showing variation of photocurrent with voltage for two intensity incident radiation of equal frequency and different intensity. The phenomena known as photoelectric effect occur when the metal surface is exposed to radiation with the right frequency. It is electron one. Okay, yes, next. The graph is plotted between the stopping potential and the frequency of incident radiation. The product of slope of straight line obtained and the magnitude of charge on electron is equal to how much? It will be equal to h. Okay. Why this? I'll explain you in the next topic.